Why do scientists spend time looking for water on other planets? Why is water so important? It's because water is essential to life as we know it. Water is one of the more abundant molecules and one of the most critical to life on Earth. Water comprises approximately 60 to 70% of the human body. Without it, life as we know it simply wouldn't exist. The polarity of water molecules and its resulting hydrogen bonding make water a unique substance with special properties that are intimately tied to the process of life. Life originally evolved in a watery environment, and most of the organism's cellular chemistry and metabolism occurs inside the watery content of the cell's cytoplasm. Special properties of water are its high heat capacity and heat vaporization, its ability to dissolve polar molecules, its cohesive and adhesive properties, and its dissociation into ions that leads to generating pH. And understanding these characteristics of water help us understand its importance in maintaining life. And in this lesson, we will study the structure of water, the properties of water, and we talk about the water pollution. So first, structure of water. We know that water molecules are formed of one hydrogen atom with two hydrogen. We know that water molecules are formed of one oxygen atom combined with two hydrogen atoms and joined together by an angle of 104.5 degrees. So the water, one oxygen, two hydrogen, and the angle between the two hydrogen is 104.5 degrees. And because there is a slightly bigger electronegativity between oxygen and hydrogen, the water is a polar compound and the molecules of water are linked by a hydrogen bond. So what is a hydrogen bond? We say that the hydrogen bond is a weak electrostatic attraction force that arises between the molecules of a polar compound. So to understand this, we have a water molecules. The oxygen has slightly bigger electronegativity than hydrogen, so it attracts the shared electron toward it, and that gives the oxygen slightly negative charge, and the hydrogen gain slightly or partially positive charge. And by introducing another water molecules, the oxygen has negative charge and hydrogen has positive charge. So we have two poles now, and whenever we have positive and negative charge, they attract by electrostatic attraction, so forming a hydrogen bond. So all you need to know that the hydrogen bond, it's a weak electrostatic attraction arises between molecules of a polar compound. So in the water molecules, the hydrogen between oxygen and hydrogen inside the water molecules are polar covalent bond. But the bond between the hydrogen and oxygen between different water molecules is a hydrogen bond. So what are the properties of water? Water exists in three states. Water is a good polar solvent. Water has a rising or has high heat of boiling and freezing point. Water density decrease on freezing, has natural effect, and we use electrolysis of water. So first, water exists in three states: liquid state, gaseous state, and solid state. So water exists in all states of matter: solid, gas, and liquid. Second, water is a good polar solvent. So if we have salt in water, the salt will dissolve. If you put sugar in water, the sugar will dissolve. But if we put an oil in water, the oil float on top of the water and don't dissolve in water. So both sugar and table salt dissolve in water, while oil doesn't dissolve in water. So we know that salt is an ionic compound. So it forms from positive ion and negative ions. And when we put water, the positive part of the water attract the negative part of the salt, and the negative part of the water attract the positive end of the salt. So waters attract or pull the ions of the salt apart, and that's what makes the salt dissolve in water. So the negative oxygen end attract the positive sodium ions, and the positive hydrogen end attract the negative chloride ions of salt, and this force of attraction pulls the ions apart. And the same thing happens with sugar. Sugar consists of crystals of many molecules. So the molecules of sugar combine together or attracted or bonded together by a hydrogen bond. And in putting sugar in water, the attraction between positive and negative end of waters and sugar molecules pull each individual sugar molecules apart from the crystals, and that's what makes the sugar dissolve in water. But all we need to know is the water is a good polar solvent because most ionic compounds such as sodium chloride dissolve easily, and some covalent compounds such as sugar dissolve easily in water. Why? Because they form hydrogen bond with water. So water a good solvent because it dissolves ionic compound and dissolve some covalent compound which form an hydrogen bond with water. The rising of water boiling and freezing point. So due to the hydrogen bond, the pure water boils at 100 degrees Celsius and freeze at 0 degrees Celsius. Water density decreases on freezing. So the water density in solid state, the ice, is lower than the density of liquid water. Why? Because as the temperature of water decreases below 4 degrees Celsius, the water molecules reshape themselves into crystals, hexagonal shape, and that's increase the spaces between the molecules and therefore increasing the volume of the water, so their density decrease. So why the water density in ice lower than liquid water? Because when the temperature of water becomes less than 4 degrees Celsius, water molecules are collected together by hydrogen bond, forming ice crystals which have hexagonal shape. So large volume and large number of spaces between them, so density decrease. And because of this behavior, the ice crystal float on the water surface, helping in the preservation of life in aquatic creature in deep water. So if we have a pond or a sea, and in winter, when the water freezes, the ice float on top of the water, keeping the whole column of the water warm enough for the creature to live. So here we have a liquid water, and as the temperature decreases below 4 degrees Celsius, they reshape themselves into hexagonal shapes, so increase the spaces between the molecules and therefore increase the volume, so the density decrease. So why, when water freezes, its mass don't change? So as we know that density equal mass over volume. So that decrease in density compensated by the decrease in the volume, so the mass remain constant. And while you're putting a glass bottle of water, the glass explodes, because when we put water in the freezer, the water freezes, as it freezes, the volume increase, pushing the sides of the glass bottle, cause it to explode. So because when water freezes, its volume increase, so the bottle explodes. So we talked about that water exists in three states. It has a high boiling and freezing point, the good boiler solvent, and its density decrease on freezing, and all those four, we call them physical characteristics. Now we talk about the chemical characteristic of water. The first is that water has a neutral effect. So pure water has a neutral effect on litmus solution. So we have two litmus paper, red and blue, and in putting them in water, their color don't change. So we have water, H2O. So water form of one positive hydrogen and one negative hydroxyl group. The positive hydrogen ion is responsible for the acidic property, and the hydroxyl group responsible for the basic property. So because we have one positive ion and one negative hydroxyl group, so the water don't have acidic or basic property, and that's why the water is neutral effect on litmus paper. So why pure water has neutral effect? Because pure water formed of positive hydrogen ions, which are responsible for the acidic property, equal the negative hydroxide ions, which are responsible for the basic property. The second chemical property is the electrolysis of water. Lysis mean decomposition. So electrolysis mean the decomposition of water by using electricity.
Hi guys, this is a strange looking instrument called the Hoffman voltmeter. Let's just explain it. We have a source of electricity, direct current, and we've got positive, negative terminals attached to two terminals that are inside some water with a small drop of sulfuric acid just to allow it to conduct electricity. And the electricity splits the water molecule up. We call that electrolysis, the splitting up of water. Electrolysis is the term we use for a chemical reaction induced by electricity. So the electrolysis of water is occurring. And you can see bubbles bubbling up in these two tubes. Now the tubes are there specifically to collect the gases separately. So let's have a look where the gas levels are at the moment. We've had enough gas to push this one down to there, and that's at the negative electrode. And we've had on the other side half that amount. And if you remember the formula of water being H2O, clearly this is hydrogen, and there's twice as much as the oxygen on the other side. Okay. To prove that it is hydrogen and oxygen, we're now going to ignite the hydrogen, and we know it makes that little explosion, the popping sound, and there we will see what it does to a glowing stick. So to get the gas out, I put it in a test tube, and I slowly open this, and we will see the level of this liquid go up as the reservoir drops. It pushes down and pushes the level of the hydrogen up. There we go. So this is pretty much full of hydrogen. Now we're going to go and take it and see what happens. The characteristic popping sound of hydrogen exploding. On the other side, we're going to try and collect the oxygen. Right. Well, while we get that ready, let's just ignite the glowing splinter. Now I blow the splinter out, and I'm going to put it into the tube that's got the pure oxygen in. Can you see there? Oxygen supports combustion, and it made it not only glow brighter, but actually burst into flame. So pure oxygen will make a glowing splinter ignite and burst into flame. To contrast that, I want to show you what happens when I stick a glowing splinter into a tube full of air. You can see it just snuffs it out pretty quickly. It certainly doesn't glow brighter or ignite.
So to do an electrolysis, meaning the decomposition of splinting water by electricity, we use a device called Hofmann voltmeters, which consists of battery, a source of electricity, the two terminals, the positive part, a positive part which called anode, and a negative part which called cathode. And as the water split, the oxygen, because it's negative, collected or goes or attracted to the positive part of the voltmeter, and because the oxygen, the hydrogen is positive, it attracted to the negative part of the voltmeter. And now let's do the experiment by ourselves. First, let's add the dilute sulfuric acid, and we add the dilute sulfuric acid to increase the conductivity of water. Let's pour the dilute sulfuric acid. Now let's connect our battery. The anode is the positive terminal, the cathode is the negative terminal, and notice the amount of gases. The hydrogen is double the amount of oxygen, because water consists of 2 hydrogen atoms and 1 oxygen atom. So now let's make sure that this is hydrogen and that oxygen. Popping sound is the characteristics of hydrogen burning, and the oxygen increase the flame. So we use the Hofmann's voltmeter to split water by electricity in a process called electrolysis of water, and by doing so we collect the oxygen in the anode and the hydrogen in the cathode, and the amount of hydrogen is double the amount of oxygen, and the hydrogen burn with a popping sound while oxygen increase the burning. So the acidified water So we use the Hofmann's voltmeter to split water by electricity in a process called electrolysis of water, and by doing so, we collect the oxygen in the anode and the hydrogen in the cathode, and the amount of hydrogen is double the amount of oxygen, and the hydrogen burn with a popping sound while oxygen increase the burning. So the acidified water decomposed by electricity into oxygen gas evolve at the anode. The positive term makes the glowing splint more glowing, and hydrogen gas evolve at the cathode, which is the negative end, burn with a pop sound. And the ratio between the produced hydrogen gas and oxygen gas is about 2 to 1 by the volume, because water molecule composed of 2 hydrogen and 1 oxygen. So 2 hydrogen, 1 oxygen. So if we have 10 centimeter cubic of hydrogen, we will have 5 centimeter cubic of oxygen. So why we add few drops of dilute sulfuric acid to water? Because pure water is a bad conductor of electricity, so we add a dilute sulfuric acid to increase the conductivity of water to electricity. Last thing is water pollution. So water pollution is the addition of any substance to water which cause continuous change in the water properties, physical or chemical properties, and that change affecting the human and life. So water pollution is the addition of any substance, any foreign substance, which cause a gradual and continuous change in the water properties. This change affects the health of life of living creatures. And the environmental pollutants can divide into natural pollution. They arise from volcanic eruptions, death of living organisms, lightning. So the human can't control or don't have any part to do with these natural catastrophics. So when a volcanic erupt, it produces a huge amount of poisonous gas which pollute the environment. Also, a lightning strike, it sometimes causes forest fires, which produce a carbon dioxide and poisonous gases to the atmosphere. But the human activity can increase or also do harm and pollute nature by burning coal and oil, by overuse the chemical insecticide and fertilizers, and throwing sewage into the rivers and seas. The first type of pollution is biological pollution, and that's caused by mixing animals and the human waste with water. And the biological pollution causes the infection of many diseases like bilharzia, typhoid, and hepatitis. The second type is chemical pollution, and it's caused by discharging the factories' residues and sewage in seas, rivers, and canals. And those residue of factories contains heavy metal like arsenic, mercury, and lead. And as the fish feed and grow in contaminated water, they concentrated these heavy metals in their bodies, and as we eat, the marine creatures contaminated through polluted water, our body can't get rid of those heavy metals, and as the heavy metals concentration increase in our body, causes many diseases. So if we eat a fish or marine organism has high concentration of lead, that causes death of brain cells. If we eat marine organism has high concentration of mercury, that causes blindness. And the arsenic concentration causes increased rate of liver cancer. The last type is thermal pollution, and it's caused by discharging the marine water that's used for cooling the nuclear reactor in sea. So when we use nuclear reactor to produce electricity, the nuclear reactor gets too hot. So to prevent the nuclear core from exploding, we pull water from nearby sea to goes around the nuclear reactor to cool it down. So the water gets too hot, and then we discharge this hot water to sea. And that causes death of marine creatures due to separation of dissolved oxygen in water. Because oxygen dissolved in water depend on the temperature of water. So if the water gets too hot, the oxygen dissolved in water decrease, and that causes suffocation of marine creatures and cause them to die. So how we protect the water from pollution? First, by preventing of getting rid of sewage waste and factories and dead animals into river and canals. We're developing the water purification station and doing a periodic analysis of water used in drinking. So we develop the stations to purify water and periodically analyze the water looking for any heavy metals or microbials. Disinfection of drinking water tanks, which are found in roof of buildings. So if one of us have a water tank above where he lives, he had to periodically cleaning the tank and to clean it from any heavy metals or microbes. Spreading environmental awareness among people. We have to educate people. We have to talk about water pollution to make people aware that whenever they use a water polluted, that will affect their own health. And reduce saving bottle or store water in plastic bottle, because water are purified using chlorine, and that chlorine react with plastic, and the result of reaction from chlorine and plastic increase the rate of cancer.